Hi there, Eric here. So in my other videos, I've taken you through bits and pieces of what I call a Stoich problem, short for stoichiometry. But what if you've got a full-blown word problem that goes over lots of different aspects? How do you bring them all together? Well, let me show you. So let's say you get this question. Sodium hydroxide plus aluminum react to form sodium aluminate, and there's the chemical formula of Na3AlO3, and hydrogen gas. If 24.7 grams of aluminum are used, A, how many grams of sodium hydroxide are needed, and B, how many grams of sodium aluminate are produced? Well, there's a lot that's set up in this, and you might be thinking, how do you solve this? Well, here are the steps you're going to need to do. So, first thing we have to do, we have to get a balanced chemical equation. Now, we didn't even have chemical formulas, so we're going to get the formulas and then balance the equation. Then we need to figure out what we know and what we need to find by going back and rereading the problem. We need to plan out our steps to get from what we know to what we need to find, and then we need to do it. So in my other videos, I've shown you how to use what I call the Stoich chart. And the Stoich chart is great in helping you to figure out what you need to know, what you need to find, and how to get from A to Z. It's not going to give you a balanced chemical equation, and it's not going to do the math for you, but it does help you organize everything and get going. All right, let me go over to my notebook. Okay, so here we are. I've got the problem written down in my notebook, and we're going to go ahead and start writing out the chemical formulas. So, first chemical formula we've got here is the sodium hydroxide. By this point, I hope you can look up on the periodic table and you find that sodium, chemical formula of Na, and that the charge it most commonly takes is a +1. And the hydroxide, maybe you just know this by now, it's polyatomic anion, OH, with a charge of -1. And so the +1 and the -1, they just cancel out, and so sodium hydroxide is NaOH. Next up, we have aluminum, and aluminum here, well, it's all by its lonesome. It's not in a chemical formula, so aluminum is just aluminum, Al. That was easy. All right, we have sodium aluminate. Now here, the problem went ahead and gave us the chemical formula, because this is not super common. This is not necessarily something that you would be expected to know even if you were taking like an advanced placement test. Aluminate, it exists, but it's just not that common of an ion. But just in case, so we're back to Na with a +1, and aluminate is AlO3 -3. And so the way that these balance out is you need a 3-to-1 ratio to cancel out the charges. So that's where the Na3AlO3 comes from. And last but not least, we have hydrogen gas. You might be saying, well, oh, hydrogen, great. That's just like aluminum. It's an element, so we're done, right? Except hydrogen belongs to that group of elements. I call them Hofbrinkel. These 7 elements always come paired up when they're in their elemental form. They're called the elemental diatomic sometimes. So hydrogen gas is in fact H2. So now we have our chemicals and we can go ahead and balance our chemical equation. Okay, so now we've got our unbalanced chemical equation. It's time to balance it up. The way that I find is easiest is to make the chart, and let's count up every element we have on both sides. So I've got 1 Na on the left-hand side. I have 3 sodiums on the right-hand side. Left-hand side 1 O, left-hand side 1 H, and left-hand side 1 Al. Right-hand side, let's finish that up. Keep them in the same order, by the way. So how many O's do I have? 3. How many H's? 2. And then how many AL's? Just the 1. Okay, so what do we do next? Well, there's kind of no real right way to go about doing this. I generally start at the top and work my way down. I see I have 3 sodiums on the right-hand side, so I'm going to fix that. and make it so now I have 3 sodiums on the left-hand side. Except that 3 also changed the number of O's and H's, because this means I have 3 sodium hydroxides. So I have 3 O's and 3 H's. Now, that is darn near close. We've got everything right. The NAs, the H's, and the Al, except the H's. I said H. The Na, the O, and the Al. The H's are what we have to fix. So let me show you a trick. You may or may not know this. If I write 3 halves there, 3 halves times 2 is 3. Hey, look, we're done, right? No, don't. Stop here. If you stop here, I guarantee your chemistry teacher will yell at you. We're not done. We're not done until these are all in the lowest whole numbers that they can be. But we can fix this really easy. We just need to maintain this ratio. So we have a ratio here of 3 to 1 to 1 to 3 halves. Remember, there's invisible ones here. So what's the same ratio as 3 to 1? Well, if I double that, I'll have 6 to 2. Same ratio, right? And then I have to double this invisible one, that goes to 2. And then I double this, and that goes to 3. So I've preserved the ratios. They're all whole numbers now, and there's no way to reduce this. So that's the balanced chemical equation. Okay, so we've got our balanced chemical equation. Let's go ahead and I'm going to make the chart. All right, I've got the chart done. I left the mole of reaction the same because this is an ideal reaction, so these are all going to be the same. And then let's take what we know and fill it in. And what we know from the problem was that we had 24.7 grams of aluminum. So that goes there. Okay, so what else can we fill in from here? Well, we know, or we can find out, the molar masses of all of these. I'm not going to step you through that. That'll be another video. But these are... Now, I didn't actually have to fill that one in because no part of the question asks me about that. Bit of a habit there. All right, so now what do? So we're going to do the calculations, and here, remember, in the Stoich chart, it's divide going down. Okay, so we can find out the number of moles of aluminum, and that is 0.9148. Now, what do I go next? Well, I want to come down to mole of reaction, but I haven't brought down my molar ratios yet. And that's these, the coefficients. So let's bring those down. 6, 2, 2, 3. All right, now I can find the moles of reaction. It's just 0.9148 divided by 2, which is 0.4574. Okay, and from this row, we can go back up the charts. Now, I said I filled out this one. I forgot. Oh, I didn't need to do that. How did I know I didn't need to do that? Because if you go back to the question asked for the grams of the sodium hydroxide used and the grams of the sodium aluminate produced. So we started here. And then we're going to march up to there, and march up to there. All right, so now it's just a matter of breaking out your calculator and doing the math. So one thing I'll point out is since this is a 2 to 2 ratio, I don't even have to break out my calculator. This is just 0.9148. That'll be the same. 0.4574 times 6 gives me 2.744. Might as well finish that up. So 2.744 times 40 gives me 109.8. And then 0.9148 times 144 gives me 131.7. Now remember, I said that this is your work, this is not your answer. You should always answer the question and say that 109.8 grams NaOH were used and 131.7 grams sodium aluminate, Na3AlO3, were produced. And that is a start to finish stoichiometry problem. Thanks for watching.